wait too long.
Okay. I can always stop it again. Let me just click go live.
Okay.
And we can just make sure everyone can see it.
Okay, let me
Okay,
try.
Looks to me like it's working.
Just a quick question. Should I send my presentation to you, Helen, or anyone else, or I can share it from here?
I think you can share it so you can control it, right? Isn't that the best way, Tomer?
Yeah, I think so.
Yeah. So I see on YouTube that it's already broadcasting, so that's great since like that's taken care of.
Yeah.
So and all we've got left to do is to make sure that all of the presenters become co-hosts so they can share their screens when you tell them it's time. And then I think you're ready to go.
I'm not sure if this is relevant, but I'm obviously not a co-host at the moment, and it looks like I can share my screen. Oh, never mind.
Yeah.
Never mind. I can't.
I think I can share my screen too, so shouldn't be a problem.
I think you're a co-host, Paratosh.
Yeah.
Oh yeah, okay, maybe. Then
Yeah, never mind. I thought it was working, but it's not.
But Tomer, if you give me host privileges back, it's not going to do something to the
You
live
already
stream.
are, and it seems to be working. So let's just keep things the way they are and not change hosts anymore. You're the host, and you'll stay the host for the remainder of the session. So it's all under your control. Apart from the streaming thing, which is apparently running from my computer, so I can't leave. But I wasn't planning to leave anyway. So no worries. But I think this is it. Just wait for the other presenters to join. Make sure you make them co-hosts too beforehand, so you don't so it doesn't take up any of your time during the session. And good luck.
Okay, perfect. Can you see my screen now? Is this the one you showed, Tomer?
Yeah.
This background slide, or did you show this one? I don't remember.
So while waiting for people to join, I used the first one, just so people know that it's happening, instead of just seeing a blank screen when they join, if they join early. And then when we started, I moved to the agenda to show people what the plan is for the remainder of the day. So I think for now this is great, because now when people join, this slide is what they're going to see. It looks very professional, I think.
Okay, perfect. All right, so then we are good to go. I just need to make the other people co-hosts, and then we will start again in 12 minutes.
okay. Yeah. So see you later then.
Yes, see you in 12 minutes.
Just one other small thing from my side. I was wondering if there's a specific title you want me to put. If you can just send in the chat, and then I can make the title of the live stream what the name of the conference is.
Oh yeah, okay. Let me do that. Man, I'm such a Zoom noob.
You can just go to this next slide, to the second one, and copy the contents from there to the chat.
Okay. And then the chat is there. Okay, I think. Where's the chat?
At the bottom, I think it should say chat. I'm actually not sure what your screen looks like.
Wait.
But actually,
yeah, go back to the main Zoom window, and you'll see a chat option at the bottom.
I see chat, and then I just have to click the person I want to talk. Oh wait, what am I doing now?
Just type it in the bottom of the chat box.
I only see my. Wow, I'm so bad at this. Chat.
I can just copy it from there. Actually, I can just see this.
Okay. Where's the chat? Why am I so bad at this? Wait, when I'm sharing my screen, I don't see it. I have to stop sharing.
Yeah, sometimes the screen sharing messes things up a little bit.
Okay, now I see the chats. Okay.
Okay. Thank you so much. Perfect.
There you go.
Okay, so it looks like everything's working well, and I hope everything runs smoothly.
Oh, thank you. Appreciate
Good
it.
luck.
Helen, one last thing from my side, really quickly. It's you see that it's recording, right? So since we started, it's been recording everything, all our chats and everything.
Oh, okay.
So obviously we don't want all of that to go in the official recording that that's going to go up on YouTube later. So
Yeah.
that means that I will. It's recording onto my institute's servers at the
Okay.
moment. So the video file that's going to get recorded, I'll send you a download link so you can download it later and
Okay.
cut out of these first 30 minutes and then send that edited file. And maybe you might need to cut out other stuff, like if any of the presenters don't want their things to be available on YouTube later, or to cut out the discussion parts and so forth. You'll have to edit that out and then send the edited file to maybe to Nina, and she will upload it to the ISAE YouTube watch on demand kind of thing, I think.
Yeah, I'll upload it if you send me the edited file.
Yeah. Okay. So yeah, that's just a note for later for you.
Okay, but was there something that we're not supposed to record the discussion?
Yeah. Well, we're recording everything because it's really likely that if we stop recording and then start recording again in the middle of the session, it's likely that we're going to forget to start recording again. So
Okay.
what we decided to do is just to record everything, but keep it private on our just on our computers, so we can edit those parts out, and then the public file is going to be the edited one that you send back to Nina.
Okay, I got it. Okay, sounds good. I think
Yeah.
we're all on the
So-
same page then.
Excellent. So see
Perfect.
you in a few minutes.
Good
See
luck.
you in a few minutes. Okay, bye-bye.
Bye.
Helen, keep the slide on, the beautiful slide, so people know that it's happening.
Okay. I'm going. I'm going. Okay, you see it now, right?
Well, we see the PowerPoint thing. Make it into a slideshow and then it will look cool. Yeah, that's the one. Great. Okay, see you soon.
Okay, see you. Hey, Alon. Hey, Hiroki.
Hi, Helen. How are you?
Oh, hold on. I'm not hearing anything. Hold on 1 second.
You hear me?
What's going on here? Alon, I can't hear you. Is it just me that can't hear you?
Yes, I can hear you very well.
Oh, you can hear. Okay, now I can hear you, Alon. Can I hear you, Alon?
Yeah.
Yeah, okay, yeah, got it. How are you guys doing?
Very well. How about you?
Doing fine, you know, surviving. Oh, I see Julia's here.
Hi.
Hi, Julia. I'm just making you a co-host now.
Great, thanks.
And then we have, let's see. Yeah. Hiroki, should we get started, or should we just wait a minute?
Sure.
What do you think?
It's very up to you. How do you think? I'm over. It's okay.
Okay. Maybe we should just go ahead and get started since we have a pretty tight schedule.
Sure. Okay.
So would you like to start? Then maybe I can just go.
Okay, thank you, Helen. Yes, thank you very much. I am Hiro Tanikawa from Nagoya University. I'm now chair of the ISI-SEM the section. So this is ISI-SEM Perpetual Online Conference Session 8. Today is the 28th of April 2021. So I hope everybody being safe, and it's a very severe current circumstances around the COVID-19 situation. But I really, on behalf of the all board members of the SEM, I welcome you all to for joining here online via Zoom, and also I think there's some YouTube Live as well. And we actually, as a SEM, especially the board member, we try to keep having some communication through whole SEM members, as well as the whole ISIE, and also the researchers, and also the other the person who have the interest of our SEM concept. The SEM is, as you know, the socio-economic metabolism. So that we have very having some linkage, focus on the linkage between the environment and also the social ecology, social things, and also that we are trying to thinking about for the metabolism as well. So today is a really nice topic of the socioeconomic metabolism and the oceans, which is thanks to Helen that we have the very success to having this online sessions. And so I hope to have the lots of idea from we have 4 presentation. Yes, so hope to enjoy. And the past video of this our SEM Perpetual Online Conference is on the YouTube. And so that you can check, please check later. And if you have any more interest, please join the ISIE, and also the SEM, please join the SEM members as well. So please check the website as well. Okay, back to Helen. Thank you for arranging everything for today. Helen.
Thank you, Hiroki. Appreciate that. As Hiroki mentioned, we have 4 exciting speakers today, and I'm really happy to present them to you. We have Professor Tamar Mukov. Apologies for mispronouncing everything here, but her and Professor Alon Chapon from BGU and Tel Aviv University, they're going to talk about omega-3 fatty acids. So this is a topic that's near and dear to my heart and plays a huge role in ocean ecosystems, but also in human health. So that'll be a really exciting topic. And then we have Professor Julia Blanchard from the University of Tasmania. And again, she's going to be talking about topics that are very near to my everyday interests, research interests, but also professional interests in my job within the feed sector, the aqua feed sector in particular. And she's going to be looking into the connections between food systems across the land and sea, because these two are very closely connected, as you'll soon hear. And then we have Professor Paritosh Deshpande from NTNU, and he is working on ocean plastic. So this is a very exciting topic, very timely, I have to admit. Lots of people focusing now on ocean plastics and the severity of the problem. And then finally, we have Christina Berg from TOMRA, and she is working on the circular economy, especially on the ocean plastics problem, but in real life. So she's actually looking for industrial solutions for recycling plastics. And she also engages in all-female sailing trips where she goes out and takes samples and measures ocean plastics to see what our effect really is on the oceans. So we have these 4 really interesting presentations, and I will not take up more time here and instead hand the word over to Tamar and Alon. And I think you guys are both co-hosts now, so you can share your screen. I can stop sharing. Can you two share your screen now in your presentation? And I can mute myself.
Okay, let me try and do that. Yes. Oh. Okay. Can you see my presentation?
Yes, it looks very good.
Okay, thanks so much. So thank you very much. It's to be here. Thanks, Helen, for the invitation. I'm really looking forward to this session. So my work is, as a scientist, has been always focused on environmental issues, but also related to nutrition. And in the last couple of years, I've been also diving into the oceans and looking for these links, synergies, trade-off. And one of those projects is Omega N3. And it's an ongoing work, and I'm really looking forward to your feedback. It's an ongoing work with, of course, other collaborators, Tamar, Helen here, that has done sort of the initial work that this work is based on, Jessica, Max, and Christopher as well. And so this is the project that we're looking at, Omega-3. So just sort of like a very short and quick intro of global aquaculture and capture fisheries and their expansion over the last decades. You could see that capture fisheries in the orange and red has been stagnant over the last decades, and aquaculture production has been skyrocketing, increasing fourfold over the last 3 decades. And so, in fact, it's actually the largest human food sector that has been having the highest growth rate in the last few decades. Of course, you could see also the disparity that capture fishery is mostly coming from the ocean, whereas aquaculture now is mostly coming from inland waters. And so there's a lot of prospects on how to expand aquaculture into the oceans, what is called mariculture. But this is sort of an introduction to show you the sort of sources of aquaculture and capture fishery to global food systems. At the same time, subdiets is one of the largest health burdens across the world. And although we know that there is enough food in the world produced today, on an average, there's large disparities of health costs. Here you see countries that are inflicted in child stunting, which is a low height to age, wasting, which is a low weight for height. But also in the last several decades, we see very large and growing overweight, both in children and And what's fascinating, as you can see here in this very nice graph, is that it's actually the multiple malnutrition impacts in several countries occurring at a certain tree at the same time, where some countries are inflicted more than others by these multiple suboptimal diets. These are some numbers that we have today associated with suboptimal diets. And what I highlighted in these black ones are the countries that are dependent on fish for their diets. You can see many of them reside in these regions of multiple malnutrition impacts. But the issue of fish is actually more about micronutrients than protein. On a global scale, their contribution to protein is quite low, but in terms of nutrient is where the numbers are larger. Some micronutrient deficiencies are a very large public health concern, and an estimated 2 billion people suffer from insufficient micronutrient intakes on all sorts of levels. Omega-3, and what I refer to here, it also in this presentation, is the EPA and DHA. These are polyunsaturated fatty acids, not to be confused with other omega-3, and they're also associated with health burdens, are essential for human diets, but are of course sourced in small numbers in many countries around the world. Falling wild catch, or due to overexploitation, climate change is expected to impact 10% of the population, mostly in developing countries. And the potential of nutrient yield from wild catch is often not directed to local consumption in countries most of need. So declining biomass of fish, climate change, overexploitation, a lot of those nutrients do not make it to domestic consumption because of large exports, and also inflicts very large human health impacts. Aquaculture can alleviate some of these micronutrient deficiencies, and we've seen this very large increase in aquaculture. But what my work and others show that aquaculture is not driven by nutritional optimization. It's more direct, it's more expanding because of economic and demand. And so looking at aquaculture from a different angle that brings in nutrition, what we call nutrition sensitive aquaculture, is very important. And this is part of what I will now. This is work by Helen that was published in Nature Food last year, showing the global network of omega-3. It's very complicated, and I don't want you to go through each one of those paths and stocks, but generally it's a movement from left to right, where you see the omega-3 sourced from primary production, going up the truffle, then moving to the right into the capture phase. So this is already moving into the human systems of our these omega-3. And then they could basically go into two different paths. One is going to direct consumption, and this is what you see on the upper arrows. And then lower one is what we call fish meal oil. So some of those fish are converted inputs to the aquaculture industry. And then all the way to the right, there are losses, and then to human consumption, ending up on your right, which is what says here eaten, and it's estimated 420 kilotons per year. And so focusing on the human parts, when I saw this research, I said to myself, well, is this optimal? I mean, it's critically, it's a very critical nutrient, and it's sourced from the environment. And we know that we have reasons to suspect that this resource is going to decline. But are we humans in our system it wisely, or could we do better? And so, and this was my kind of focus, looking at network, which is the starting base for my exploration to that question. And so I wanted to look at 3 points across the supply chain. Of course, aquaculture, which uses fish meal and oil as inputs, but then there's omega-3 that comes out of it in farmed fish. And then looking also at the unavoidable food waste, which is byproducts. And today, more and more of these byproducts are utilized for fish meal and fish oil. So there are more arrows coming from number two towards fish meal and oil. And then also food waste at the consumer side, which again, there is a large ambitious attempts to reduce that. And I wanted to explore these and say, well, could we actually improve this outcome of omega-3 consumption? And so I used Flux Analysis, which is a mathematical tool to actually design optimal processes within interactive networks. It uses actually a set of linear equations and to optimize the cost function, which here is the output for human supply. Again, it has rules and constraints to not explode. And the rules are constraints complicated, but mostly they say that, well, omega-3 in certain wires cannot exceed the current production, and all sorts of other rules to make it more realistic. And what you see is the results of this network. Colors look very similar to the previous current omega-3, but don't get this confused with the previous one. You could see that immediately to your right, the numbers increase by 50%. And this model actually optimizes the flows, just like you would a network optimizes this part. And it does this by moving all sorts of wires or circumventing inefficient hotspots. And I'll unpack this in a bit. You can understand it looks very complicated, and I know the sense, but I'll try to do this step by step. So again, focusing only on that part of the network and not all of it. This is again the current production as shown in Helen's work. You could see that about 293 go to of kilotons of omega-3 make it into the retail and household, and then there are other aquaculture. And if I just focus the optimization on these parts, only on supply and, of aquaculture, not touching the byproducts and food waste, what here is the results here. What it does, it actually identifies these species here in aquaculture that are net consumers of omega-3, meaning that there's a lot of omega-3 coming in, but very few coming out. And so what it does is just avoid having those arrows and instead pushes more through direct. So you see the higher direct consumption, and still you have the same amount of omega-3 produced here as in the production, but just with less species. And to increase efficiency, you divert more of it through wild capture fish. And so only this part already increases the omega-3 output by 30%. And now when you add this part of rerouting more byproduct fish meal and fish oil, and also reducing the avoidable food waste by 50%, you actually get to the final results that you see, you've seen in the previous graph. So you see now that this wire actually is recycling of byproducts. This pushes more feed into the aquaculture, but eventually we have a larger wild fish consumption, and this ends up as having 50% more omega-3. And this, of course, is a very interesting result because it shows that the system is inefficient, and if we reroute omega-3 more efficiently, we could have more omega-3 produced for human consumption. And when you see the current omega-3 production against the optimized results of our model, and you compare that to omega-3 required globally, and you have this per year, you could see that by implementing this perhaps atrocious model, but you could see that we could nearly close the nutrition gap between demand and supply. Of course, here you see what is the based on health requirements, not the actual demand, but it shows us that we could actually, by implementing some of these changes in the network, actually have more omega-3 available for human consumption. But what's also interesting is that this requirement is going to grow into the future, and you can see here by how much in the next several years. And this is, of course, on changes in the population and age and sex structures actually in Africa, but it sort of gives you an estimate of how better we can have our systems designed currently to produce more omega. And so to wrap up my talk, I wanted to show that we really need a planetary health approach to omega-3 to meet this dual challenge of dwindling resources, but also a high requirement in human systems of omega-3. Rewiring the production to circumvent inefficient spots, recycling and reducing weight could all increase the nutrient supply of omega-3 by 50% without changing the resource base. So all of this is done when we focus only on the human part, not touching the amount of wild catch. Meeting this ambitious supply suggested by our model can nearly close the present nutrient gap. This was what the previous graph was showing. Exploitation, climate change, and homeoviscous action will all reduce global omega-3 supply. This is, of course, contrasted against the growing supply, the growing requirement of omega-3 into the future. The homeoviscous adaptation, if you are wondering what it is, it means that the content of omega-3 in fish is going to decline. This is a mechanism that is within fish and actually in many animals, their membranes to have the fluidity of it, reduce the content of saturated versus unsaturated fats. And so we're likely to see also affecting the omega-3 content of fish into the future as the oceans become hotter. Of course, there's other novel sources of omega-3, and we should acknowledge this. And these are very important sources that are becoming more and more available. But improving our current efficiency of the system is very, very important. And I think it could serve as sort of fillers in the short term as these novel sources become available. And lastly, managing fisheries and directing aquaculture development using a nutrition-sensitive approach will, of course, require further research, more policies, and, of course, consumer acceptance. Thanks very much.
Thank you, Alon. Really appreciate that. Super interesting talk. I just wanted to open up first. Yeah. Open up to the floor. Does anyone have any questions from the audience? And feel free to write them in the chat or just shout out or raise your hand and we can unmute you. And if not, I have tons of questions. Yeah, okay, so maybe I'll just go ahead and start out the discussion. We have 6 minutes for a discussion, so we have lots of time here. I was wondering more about this homeoviscous adaptation stuff, Alon. How severe is this problem? Is this really going to affect the resource base for omega-3 significantly? Are we talking 20%, 30%?
Yes. So I think there's a very nice paper that we're also actually referring to in our paper that we're writing now. And this, of course, that doesn't affect the current model. I am only looking at the present omega-3 network, but there's a very nice work, and I can later the reference of trying to map how omega N3 is going to decline based on all various different climate scenarios. So of course, the higher the temperature of the ocean increases, the more we will see dwindling of these N3 content. It can go, I think, as much as 30% decrease. That's a lot. And when you factor in the fact that most models today show decline in animal biomass of the oceans, of course, there is large disparity because I think omega-3 is more in the colder species and not the hot species. But again, when you factor this, all of this, it really is showing declines in these supplies into the future and in very large quantities, I think.
Okay, yeah, that's not great. That's going to have a huge influence over the entire system, of course. And so we're just going to have to get better at how we use omega-3. Do we have any follow-up questions or anything from the floor? I don't want to take up the whole discussion myself. Yeah, Julia?
Oh, fantastic talk. I really enjoyed that. I was really interested in the modeling approach that you used there. And I guess I had some questions about the sort of the boundaries of the human system that you're considering. So I understand that it's based on a fixed resource base. So, you know, once you have that forage fish that's either going to be shunted into aquaculture or direct human consumption, that's kind of what's being sort of rewired in your model. But I just wondered about whether there were any economic components there, or, you know, like how does the optimization work?
Okay.
Maybe that's too big of a question.
No. So of course, this is only based on optimized low. It has no economic consideration. The economic or all of the other rules and constraints in the model are sort of like things that we impose. They could be, so it's sort of like implicit in it. So for example, for one of the constraints was that aquaculture cannot increase more than it is now. Okay, so it means that certain fisheries could be closed, but cannot expand more. Okay, so that makes some sort of an economic reasoning. Of course, I'm not inferring that some of these fish types can be closed in A, but it's sort of like a toy model that we should understand, that it gives us some sort of a feeling as to what could be those additional amounts that we could sort of squeeze from the system. I'm not in any way saying that we should all be eating just one or two fish species, but it just sort of gives you how much potential of the system to actually produce more omega-3 for human consumption. And so it's only based on flows of omega-3 substances. It has no economic, it's more of it's sort of like these kind of rules and constraints have economic reasoning behind them, but it doesn't have that sort of explicit in the model.
Okay, so it's going to maximize efficiency.
Yeah.
Of omega-3 flow. Yes, okay.
Yeah.
I really look forward to reading the paper. Thanks a lot.
You're welcome.
I see Tomer has his hand up. Tomer, go ahead.
You're muted.
Yeah, I didn't start talking yet. Thanks. Thank you. This was really cool, and I think the method is awesome, and I would like to learn more about it. I think we could probably use it in lots of other socioeconomic metabolism studies. But my question is actually, I think it might be a bit related to Julia's question about the optimization here. It optimizes for one thing only, right? What about, say, food choices? And is there any consideration of, say, consumer choices, what they would like to eat or what they prefer to eat? Is this taken into account? Or how to take that into account?
Okay. So again, these kind of considerations, and we've also had some pushback on this because what it does, it actually so I mean, explicitly in the model, you have a dietary shift towards species that have better efficiency of converting omega-3. So this model optimizing omega-3 actually also means that we would consume other more efficient species. So you could actually say, you could add to this model as sort of a follow-up. I would like to have diversity of diets in there, for example. And you could then actually decide that your boundaries, each one of those flows could be controlled by the model. I can say that each one of those species could, the results of the model could be within this low and high value. And then the model will choose which one to optimize the cost function. I can play around with this if I want to. I did not. I just wanted to sort of like get a feel of how much I could increase omega-3 human consumption if this was my intention in life. Of course, nobody is going to increase only omega-3. There's other nutrients and other things. But I think it's sort of, we have to realize this is a toy model. I'm not implying in any ways that people should own carp. But I think it sort of gives me back of the envelope intuition as to how much more I could get omega-3 from this system, which now you could see is very inefficient. Again, you can play with these boundary conditions to use some of what you were talking, economic duration, consumer acceptance, or other things that could then be controlled by the rules and constraints of the model.
Yeah, if I could just jump in and add just a note. I mean, the way we were thinking about this is more of, kind of an analogy to, what if everyone stopped eating red meat tomorrow? What would happen? How could we optimize the food system? And then started looking into aquaculture and like, what if, the only thing we cared about, right, was omega-3? Could we even get more out of what we already have, right? So can we increase the resource efficiency where the resource here is omega-3? So it relates to a lot of, I guess, other work in industrial ecology in that sense. Anyway, just wanted to throw that in there to make the connection maybe for those working with buildings, for example.
Okay.
Sounds like a delicious answer. For some reason, I feel like salmon for dinner tonight.
I think that's the opposite of the message, but
You want carp sushi today, Tomer?
I'm just hungry.
Always.
I think we need to move on now, and it's my pleasure to introduce Professor Julia Blanchard from the University of Tasmania. Now, she's not someone that has been inside of our ISE SEM community, but her research is really related. So I think this is an excellent opportunity for us to show some research that is not directly SEM, but is certainly related. And we have, I think, a lot to learn from other communities here. So without further ado, Julia, go ahead.
Thanks, Helen, and thanks for inviting me here. I was going to say that I'm a bit of an outsider. I'm a marine ecologist, ecosystem ecologist, who's become interested in the connections with food systems on land. And so I don't know if that's almost like the opposite journey to you, Alain. But anyway, so I'm going to give you a little bit of snippets of my research of the past 5 years, which has involved exploring these connections between food production ecosystems across land and sea. And of course, am I actually sharing the right screen here? The full?
Yes, you're good.
Yeah, thank you. I always get that wrong. Well, science is very much a team effort. And so I really have to acknowledge the work of my PhD students, postdocs, collaborators here at the University of Tasmania, but also internationally. And so one of the things that we are really interested in and has become increasingly important over the past several years is actually kind of putting together these different food systems. So for so long, I'd be reading research on food security or the impacts of climate change on food systems, and terrestrial and marine systems studied completely in isolation, and even aquaculture and fisheries in the marine environment studied in isolation. So we have these different silos, and I became really interested in trying to enhance our understanding of the interconnections across these. And so we did some comprehensive review work that highlighted the ecosystem connections, the connections associated with climate change, the livelihood connections, and also feed interdependencies in both aquaculture and agriculture. And that's something that I'm going to focus on a little bit later in the talk. So aquaculture is very much, central to these connections, relies both on resources from the land and marine systems, particularly, I'm talking here, fed aquaculture by these feeds. Now, I mentioned that we have these silos, and so a lot of my research relates to projecting climate change impacts on marine ecosystems globally, and the consequences for societies that rely on fish for nutrition, food, and livelihoods. And so I'm part of a big program called the Intersectoral Model Intercomparison Project, and the lead of the fish component of that called FishMIP. And I mentioned that the studies previously, you might see a map just purely with the marine component colored in, and then another paper just with the land. So it hasn't been that long ago that we've actually started combining this information from our global models. And so these are the results of ensembles of global marine ecosystem models and on land vegetative crop models that we put together to show that the ceiling of production is projected to fall under climate change. And Alon, you mentioned this in your talk. This is kind of what our projections show. This is from the last round, so it's CMIP 5, and we're working hard to update this. But by putting this information together, we were able to do a country level assessment, which shows that for the vast majority of these countries, when we think of potential production, so think of that as the production ceiling or the ceiling of supply, we've got declines across both realms. So that's a very serious issue for ecosystems, but also for people reliant on those. Now, this is a long-term projection, but looking also in the shorter term, what we've been doing is analyzing time series of production from the FAO. And this is work led by one of my recently completed PhD students, Rich Cottrell. And here we looked at increasing shocks across different food sectors. We found that the frequency of these shocks was increasing across crops, livestock, fisheries, and aquaculture. And this is important because the combination of these shocks in a system that's all interdependent is going to blow up at a time when, well, right now, COVID, for example, a major shock to the system. And there's a combination of different drivers happening all at once. So these are causing threats to future food supply, but also through these different feed pathways as well. Now, when we put these systems together, we didn't actually have a network that connected these systems. And when we tried to do that, and when we also tried to look across lots of different food types, we found a lot of blanks. So we looked also in the literature about the environmental impacts of different food systems. So here, so far I've talked mostly about the risks to food production via climate change and other drivers. But of course, all of these food systems pose environmental impacts as well. And of course, those studies have tended to be siloed also. So one piece of work that we did was to do a pretty rapid literature review of particularly life cycle analysis studies that looked across at least more than 2 different food systems, and compiled this just to see where most of the studies actually focused on. And so you could see the yellow bits on this graphic, GHG, the climate impacts of food systems, particularly amongst livestock, has been a key focal area for a lot of these comparisons. But you see a lot of gray parts on this matrix of impact versus food system type. And those are areas where we've got blanks, major blind spots that we actually need to fill. I'm going to draw your attention to the biodiversity impact area, where there's a lot of blanks and gaps in our understanding for looking at biodiversity impacts of different food systems. And then if we look towards the right-hand side of this matrix, we do see a lot of, not a huge number of studies from aquatic food systems where people have actually combined the aquatic sector with the land-based sector. This is starting to change now, but there's a whole lot more work that needs to be done here. And so something we're really, really interested in digging into a lot deeper are these feed interdependencies in aquaculture. So Alon showed the growing production from aquaculture, and particularly mariculture is really expanding rapidly now too. And so this may be in many ways more sustainable, but isn't without its environmental impacts, and also isn't without its connections to the land. And so aquaculture has moved in a particular direction under the narrative that reduced reliance on forage fish is more environmentally sustainable. And certainly when we look at the declines in forage fish potential, there's part of that narrative is true. But is this an absolute kind of direction that we need to go into forever, sort of no forage fish at all being used in feed? Is it actually more sustainable to shift completely to terrestrial sources? So that's a question that we feel hasn't really been thoroughly investigated, and we're digging into under various projects. And one of them actually involves Helen and Biomer. But following a workshop that we held a couple of years ago, we started to just dig into some of the more basic signals of sustainability. So we looked at just the time series of production to see, whether food supply and feed production would keep up with each other. And so here we've got on the left-hand side, we got fed aquaculture, that's the relative production of fed aquaculture through time. And then the relative production of the major feed crops and the major forage fish species. So you can see that the slopes of these lines here are nowhere near the rise of fed aquaculture. So how can we keep the pace with that production is a major, major challenge. And on the right-hand side, we have the relative yield. Okay, so this is more akin to the efficiency. So the blue line is the catch per unit effort, a term that we use a lot in fisheries for looking at forage fish. And you can see that decline is pretty marked and concerning. If we look at the major crops used in feeds, you can see a rise there. And what we've done is looked at this in terms of efficiency relative to fertilizer adjustment since 2000. So here, worryingly, if we were to look at that decline, that could be a signal of deterioration in efficiency, but also what we're concerned about is the deterioration of the ecosystems underlying those systems. We know that the massive application of fertilizers in crops is not only has its own impacts via climate, GHG emissions and that sort of thing, but also via the degradation of soils and the nutrients that hence get released into the sea. So there's a lot to dig into there. There's also a lot to dig into in terms of the year-on-year growth rate that needs to kind of be positive to keep up the pace with this growing demand that we see in the face of that declining ceiling that I showed you under climate change. And if we look at those year-on-year growth rates in forage fish production, they're very clearly negative. And in terms of the crop yields, this is not fertilizer adjusted, they're veering towards zero. So this is of concern in terms of the actual supply. And of course, there's a huge amount of effort being put into different the use of different byproducts in aquaculture, the development of novel feeds. And so we're really interested in delving into whether novel feeds could fill this gap. Can they actually provide a solution here? So we've been looking across lots of different experimental studies and doing a meta-analyses of experimental studies to see what the potential savings in terms of forage fish oil and meal under different potential novel feeds might be. And we've been finding a lot of interesting potential answers just using simulation scenarios under future projections, particularly pointing to algae as a potential saving, mostly via the oil pathway. But there's a lot more work that we would really like to do to get a much more comprehensive understanding of how feeds can shape the sustainability of aquaculture. And this is work that we're just starting now with BioMar and my other collaborators that I named on the first slide. What we hope to develop here is something that's much more ecosystem based, because ultimately these interconnections, while they're global to local, ultimately there are a bunch of ecosystems that supply food and humanity that are all interconnected. And so we're really interested in tackling these connections to look at ways in which we might seek optimal solutions for aquafeed and the growth of aquaculture underneath these climate change scenarios as well. Now I've got a bunch of links here on this graph and then a bubble person, and this part is important because this can involve the human and consumer choices. And here in Tasmania, it's a pretty big challenge with aquaculture having so many opportunities and possibilities. But one of the main barriers is actually public perceptions about aquaculture. And so here we've got a Twitter analysis of the proportion of sentiment. And we've got a lot of really positive sentiments, down at the bottom of this plot, Northern Territory, Queensland, but in our own state in Tasmania, it's very negative. This corresponds where most of the production in aquaculture is based in Australia. And so that's a key challenge, sort of understanding and putting all the quantitative information together about aquaculture, its links to the other food systems, taking an ecosystem approach that accounts for place and the environmental, social, and economic costs and benefits is really key to communicating the opportunities that we've got for making aquaculture even more sustainable. So these are just my closing thoughts that to achieve such a goal, we need to have integrative work, not in our separate silos, but also spatially explicit understanding of these land-sea social ecological interactions to assess the impacts, trade-offs, and resilience of food systems to climate and global change. I focused a lot on feed ingredients here. These are also influenced by climate change. Often these feed ingredients are kind of hidden or ignored from some of the studies of food systems. So I think it's really important that we understand those better. Ecosystem impacts on land will interact with physical changes in coastal and ocean ecosystems. So far, most of the modeling work that happens, particularly the climate change modeling, is disconnected. So we're trying to make those connections. It's going to take a lot of work and interdisciplinary will, but that's what we're hoping to move towards. And finally, that combination of environmental, social, and economic sustainability of this alternative pathways towards sustainable feeds, I don't think is fully understood. But I feel that this has to underpin the future direction of aquaculture. So we're really excited to be developing these integrative and transdisciplinary tools, and we hope, in the coming years, hopefully I can show you some of the results. And thanks to Helen for inviting me.
Thank you so much, Julia. Appreciate that a lot. I mean, just so everyone's clear here, Julia and I are working on a project together. And I mean, Julia and Alon now have both pointed to the fact that feed is so central to the sustainability of aquaculture and to the sustainability of how we use our oceans. And it's important that the aquafeed industry takes into consideration all of these different things and tries to make improvements. And so I'm just going to take the liberty as the host to ask the first question. Julia, do you have, I mean, yeah, both, like I mentioned, both Alon and you have mentioned the central aspects of feed and how we use our feed being really important for just feeding the world. Julia, are there low-hanging fruits here in the feed sector that you see that we could just easily make some shifts to improve? Or are there maybe some kickbacks, for example, to relying too much on byproducts? Or what are you thinking?
Yeah, well, actually, when you said the low-hanging fruit, that it's the byproducts and the waste pathways that immediately come to mind as the low-hanging fruit. And it's interesting that was something that I think was more efficient, and I think if I interpret that correctly from your study, Alon. But of course, some of there are some issues with byproducts and major barriers in some countries. And, it's really difficult to think of any kind of single solution to a pretty complex system. And this is where I think this place-based approach, which integrates information from ecosystems that are sourcing to ecosystems that are at the site of production. So that's where I think our knowledge gaps are. I don't have, I can't think of what the silver bullet would be. A lot of people have suggested different marine species that are underexploited, like mesopelagics. But there's huge uncertainties around mesopelagics. And so I often feel like in looking for the, the silver bullet or the thing, we kind of miss sometimes the big picture. And so that's why I guess, actually honing in on bringing together the data and doing a comprehensive assessment is, I think, really critical at this stage, because I feel like often we'll go for the new thing, what might seem to be the obvious sustainable solution. And yet we end up then sort of saying, well, be careful what you wish for. Actually, there's all these other things we didn't think about because we weren't looking. And so, I mean, I haven't answered your question at all there, I don't think, but that's sort of how I feel about it.
Just quickly, Alon, I see you've unmuted yourself, so
yeah, maybe just add to that. First of all, thanks for your really wonderful presentation. I really liked all these connections. I've been thinking so much about it and never thought how to bring that together. I also really believe in trying to find the silver bullet is something that we learned for many years on looking at food system. And I think in almost all of these complicated systems, there's never a silver bullet. And trying to look for one is always, futile in that sense. We always have to try to find combinations of strategies, sources, and I think that's why sort of like optimizing is the name of the game here, and not, well, I have this low-hanging fruit, this is going to close now my problem. That's why I'm always very, very doubtful about sort of like these technological fixes and all sorts of things that come, trends that come and say we're going to fix the system. It's so much more complicated than that. So I really kind of, connect with everything you said about identifying these complicated issues, but there's no one silver bullet to feed or to any other of these issues, I think.
Yeah, and I think there's I really like this optimization approach too, when you look across all the, well, the network is appealing to me as well, but because what might be optimal in one system won't be optimal, you know, in another. But that doesn't mean you can't look for it. If you have the information, I feel like it's possible, and we've got the, you know, technology to look, and we've got a lot of the minds and the information. We just need to bring that all together. So if anything was the low-hanging fruit, I think it's actually bringing the data that we have together and just collaborating.
No, that's a great point. And we see that in the feed sector all the time, going after, you know, low-hanging fruits, especially the byproducts thing, leads to other problems. So what was the byproduct ends up being the main product. We see that very often, you know, with, for example, guar use. We use a lot of guar to try to offset our soy, and the guar that we use is a byproduct. But now, because there's such a demand for the guar byproduct, now we're producing guar to get the byproduct. So yeah. Anyways, there's no winning here. You have to look for a combination of things. But okay, I think we need to move on. It's really interesting talk, and we can continue maybe in the general discussion later, but let's go ahead and hand the word over to Paratosh, who's going to shift gears a little bit and start talking about ocean plastics.
Yes, sure. Let me share the screen. Can you wait? Yes, can you see my slides?
We see the presenter mode.
Oh yeah, okay. Oops. Yeah. Now it's okay?
Yeah, looks good.
Perfect. I really liked the last word that Julia just mentioned. It was a very nice presentation, both Helen and Julia. So I'll just shift the gears, as Helen said, from feed to what happens while we catch the fish in general. So my background, my name is Paritosh Deshpande, and my background is environmental management and more or less little bit of industrial ecology, but I don't really exactly belong to the Society of Industrial Ecology, because I'm only someone who applies their method. I don't contribute to improvement of methods in general. So this is the topic of my PhD. I've researched on what is the ocean plastic waste that is going on in the ocean from Norwegian fishing sector, perhaps, and we used material flow analysis for tracking the ocean plastic waste. So in this presentation, I will briefly talk about the background, what is the state of plastic pollution, and then impacts from fishing gears on ecosystem, which includes both aquatic as well as terrestrial. And then what are the fishing gears and types, because that is also important to know while going ahead in the fishing sector itself. Then I'll come to the case of Norway, talk about the brief life cycle of fishing gears, how I collected the data, and finally the results of static MFA model that I developed. And then what are the lessons learned? You can of course find the study anytime through the barcode that you can see on the left. So yes, before I begin, you all know this particular paper from, most of you have seen this paper from Jenna Jembak from University of Georgia that came out in 2015, and that entirely changed the landscape around plastic pollution in the world. Till that point, plastic pollution was kind of identified but not exactly taken seriously. I mean, nobody thought seriously about plastic pollution till that point of time. The paper highlights that around 8 to 12 million metric tons of plastic is ending up in the ocean from unmanaged due to lack of management or mismanagement from land-based sources to the ocean every year. But this study had one major limitation, and that limitation was the study actually excluded the plastics from fishing in the ocean and plastic that is entering from land-based fishing activities as well. Like if you store the fishing gears that ultimately end up in the ocean due to tidal currents and things like that. And reason that these authors gave were there was completely lack of understanding, or there was absolutely no information available about what happens in loss of plastics, or what happens with plastics from fishing in the ocean across any of the region in the world. So that was the major cause why they had to totally eliminate this particular fraction from their study. So, but does it really matter? Like, why do we need to really need to care about fishing gears, and how much is the concentration of plastics from fishing gears in the ocean? Well, first we need to identify what are the impacts of abandoned, lost, or discarded fishing gears in general on marine ecosystem. Well, the impacts are threefold. First, there are direct impacts. Lost fishing gears, once fishers loses the control on their fishing gears, it ends up in the ocean as an abandoned or derelict fishing gear. These fishing gear continue to trap unwanted marine organisms such as whales, sharks, turtles. You have seen millions of pictures on the net, on Twitter, for example, try to move this cause forward, and this is a direct impact on marine ecosystem. Another economic impact is this lost fishing gears. They keep on floating on the ocean. Some of the fractions, they keep on floating on the ocean waves or tidal zone of the ocean. Many times what happens is the vessels, fishing vessels, or even cargo vessels, their propellers get stuck in the floating fractions of fishing vessels, and that is loss of time as well as loss of money to all these particular vessels. Also, discarded or these derelict fishing gears, they also catch economically important fish species. If you see in this particular second picture, you can see an abandoned trap pot which was recovered by Norwegian Directorate of Fisheries, and you can see many crabs that are stuck in that particular crab pot, which is basically loss of valuable fish stock that fishers would otherwise catch and then sell in the market. In 1 year, Norwegian Directorate of Fisheries, they actually found 15 to 18,000 of abandoned fish traps, crab pots only in Norway. So that is the quantum we are talking about over here. I'll get back to that in the next slides. So, and the last is, of course, the heavier fractions of fishing gears. They sink down, and then they sometimes affect the coral reefs, which are sensitive ecosystem for which also act as a breeding and feeding grounds for many of the fish species. Well, terrestrial impacts. Well, this is a picture which I actually collected when I actually captured when I was visiting this Runde bird sanctuary. It is one of the very sensitive ecosystem region within Norway. It provides shelter to thousands of migratory birds during the summertime. So if you zoom out this picture and if you see closely, then you can see that the nest of the birds, instead of using grass, dry grass and things, they're actually using the green fractions are nothing but the ropes and discarded fishing gears, or degraded fishing gears. So they're actually trying to replace grass by these degraded fractions of ropes, and sometimes these birds, they actually got entangled in their own nets, basically, because these are plastic ropes and they are not really designed for them to make their habitat. So then they also enter in there. Of course, there are several studies that found that these microplastics are now entered uh, through the food chain and everything of these birds and then fishes as well. So that's a serious problem, even in Norway. Well, continuing about environmental impact, the studies are kind of rare when we talk about environmental impacts of Aldfg. You can only see guesstimates that say that, okay, around 33,000 of nets are estimated to be lost in European fisheries annually. You don't know what is the mass fraction of it. And that study was way back in 2007. There are some approximations that say that 640,000 tons of fishing gears are lost globally each year, and then up to 12.7 million tons of plastic enters in the ocean. But that excludes fishing fraction, as I mentioned earlier. But if you look at all these numbers or all these studies, what we know is we can't really design a policy for Norway or consider a region. Like I can't really, if you go and talk to the authorities in Norway and say that, oh, 640,000 tons of fishing gears are entering in the ocean globally, and then Norwegian authorities would say, no, but we are clean. We take care of our own waste every year. So fair and square, we are totally green. But that's not the case. You cannot design the thing that I wanted to say is you cannot design management practices if you do not know the data. Uh, so that was the reason why we initiated this particular material flow analysis on fishing gear, because the overall goal was to close the loop for plastics from fishing gears, but without knowing the information on how much plastic is available in the first place, you cannot really proceed. So the goal was to find out average annual purchase, repair, and disposal patterns of fishing gears, quantities of plastics entering in the ocean as ALDFG, which is abandoned, lost, or discarded fishing gears, and then annual quantities of plastic polymers, especially polyethylene, polypropylene, and nylon, collected after end of life in Norway. So commercial fishing gears, yeah, I mean, when I started, I had no background in fishery. So for me, fishing net was just a small net that you put in the water, how much it would weigh, 2 to 3 kilos. But that was my basic understanding. But yeah, I mean, that went down the drain pretty quickly when I started doing literature review, because some of the fishing gears are so the commercial fishing gears, they can weigh up to 35,000 to 50,000 kilos of plastic, and the smallest one can weigh up to 6 kilos. So there is a huge difference between the smallest one and the longest one. And fishing gear is not only plastic, it has several metal components, several other types of components, but in this particular study we only dealt with plastics in a sense. So to briefly describe about the structure of commercial fishing, in Norway we have around 5,500 fishing vessels. They do both deep water as well as coastal fishing, and they use typically trawls, purse seines, Danish seines, long lines, gill nets, and crab pots or traps per se. These are the major fishing gears that you can also see on the right hand side of the picture. The term plastics here includes polyethylene, polypropylene, and nylon combined, because these three are the building blocks of any fishing gears that they produce. Norwegian fishing gear manufacturers produce. So starting off with the basic system life cycle of any product is you design the product, and then you sell it. There is a use phase, there is a post use phase where you reuse and repair the product, and then there is end of life phase. But end of life phase of fishing gears is a bit special here, because fishers abandon, lost, or discard the fishing gears in the ocean. Many times they also abandon or discard it on land. There is a landfilling, incineration, and energy recovery, and recycling. These three are the common uh, end of life pathways for any product. That also holds true for fishing gears. So getting information was tricky, because when we started studying about this particular thing, there was absolutely no information available, only guesstimates, and you cannot do scientific work based on that. So we had to highlight stakeholder categories, and then we have to divide them based on their usefulness to provide information at a various phases of life cycle of fishing gears. So we contacted stakeholders from Norwegian Directorate of Fishes, Coast Guards, ports and harbors, Fishers and Fishermen's Association. Basically, Fishers is one of the key piece of this particular puzzle, because in any resource management studies, you get the knowledge about resources from resource users, and in seldom fishers are most neglected part of this puzzle. But we had to highlight, if you want to get the repair patterns and then reuse patterns, this sort of information you cannot get out of any literature, but you have to go to the resource users itself. And then suppliers, manufacturers, relevant NGOs, waste management companies, among the other sources. So this was the typical data collection regime that we followed for almost 15 months to 2 years, because this was literally the first attempt of mapping the life cycle flows of fishing gears. We had to also ensure that what we are presenting is not unscientific or not just another guesstimate. So we had to have the validation of result round as well. So for the pre-use phase, we contacted around 7 major commercial fishing gear suppliers in Norway that holds around 90% of the total market share. And then in use phase, we had contacted around 114 Norwegian commercial fishing companies. The interviews were conducted one-on-one so that to avoid any bias or confusion in understanding the questionnaire. And then end of life phase, we contacted regulatory agencies, beach and ocean cleanup programs that happen all throughout Norway, even the voluntary programs. And then around 13 waste management facilities spread across Norway. We chose 13 based on their proximity to receive fishing gear related waste. And then after that, we had to again contact all these particular stakeholders. Once we developed this model, we contacted all of them and presented the results and tried to refine the results and uh, with uncertainty analysis, and the final model is presented. So Fisher's knowledge, as I mentioned earlier, Fisher's knowledge was extremely important factor of the study, because without that you cannot find out what are the annual purchase patterns of fishing gears, what are the frequency of repair, and how often fishers repair their fishing gears, what is the typical lifespan of various fishing gears, what is the annual rate of fishing gear loss in the ocean, and how often fishers have to dispose their fishing gears. Uh, the basic understanding was, if you see on the right hand side, these are particularly, the first graph shows approximate repair and reuse patterns of fishing gears. So trawls, porcine and daniscine, these are one of the bigger gears, or uh, some of the gears are quite complicated in design, as well as they are quite expensive to replace. So these particular fishing gears are logically repaired more often than those that are easily replaceable, for example, gill nets or long lines. Similarly, uh, percentage of fishing gear disposed in the waste management facilities, you can see the cheaper fishing gears are easily getting disposed of every year. Long lines, gill nets and traps leads this particular uh, race. And this is an important slide, because then this slide shows what is the annual rate of fishing gears lost in the ocean every year from Norwegian commercial fishing. So long lines and traps, they are quite prone to get lost. Almost 4 to 5% of total stock of fishing gears from in terms of long lines and traps are getting lost in the ocean by fishers every year. Uh, Purse signs are the least probable to get lost in the ocean, because of course purse signs are around 35 to 50,000 kilos. This is the biggest fishing gear that you can find. And if you actually lose the fishing gears, a bigger fishing gear like purse sign, the fishing company can actually go bankrupt. It's that economically intensive uh, for fishers. So finally, based on all these calculations, we made the static material flow analysis model, where you can see around 2600 tons of fishing gears is being produced every year, is being purchased every year by Norwegian fishers. And then in a stock, they already have around 18,000 tons of plastic in terms of fishing gears, which are already there in the stocks. The repair and reuse pattern is quite well established. Fishers continuously repair their fishing gears after every single deployment in the ocean. They have to have some minor or major repairs of their fishing gears. Around 380 to 400 tons of fishing gears are getting lost in the ocean every year, out of which if you combine all the beach cleanup operations and all the ocean cleanup operations that are happening in Norway, combinedly they can only remove around 100 tons of even less than 100 tons of fishing gears from the ocean every year. That leaves up to 300 tons which is stocking in the ocean every year from Norwegian commercial fishing practices. So, and then end of life collection is important because then you know how much plastic is available. Plastic, by plastic I mean polyethylene, polypropylene and nylon. So that is around 4,500 tons of waste plastic is collected every year in Norwegian waste management companies, uh, which is available for further recycling or reuse, out of which 840 tons 840 tons and almost similar fraction goes on in the landfill, majorly because most of the major fishing gears are laden with biomass. So waste managers, they do not know how to handle, they segregate this fraction and they term that fraction as a food waste fraction, and then they simply incinerate the plastic that is associated with rotten fish and fish oil that is associated with the fishing gear related waste. So that is a major loss of resources when you burn off almost 1,000 tons of waste fishing gears. And by means of recycling, uh, in 2016 in Norway, almost every all the fraction that is being generated as a part of uh, uh, waste as a part of end of life collection, 2,300 tons of plastic was segregated and processed for recycling in other countries. That recycling was not happening in Norway. So what are the potential of recycling? Well, fishing gear uh, can easily be processed, and you can use the mechanical recycling methods to create polymers such as HDP and LDP pellets, and these pellets can be then used into walkways and, so to say, brackets that you need for aquaculture or fish farming industries. And you can use these particular pellets in almost any sorts of plastic products that are produced using injection molding method, basically. For example, chairs or the trays that you find in McDonald's or Burger King, they can all be manufactured using injection molding, and these sort of recycled polymers can be used from fishing gears. So which is a more closed loop solution. Norway being a leading aquaculture country, we have tried to develop this closed loop model within the region, and several plastic manufacturers within Norway, they are trying to use this particular recyclates such as HDP and LDP, and they are trying to replace their virgin polymers into uh, 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 virgin polymers by these recycled polymers when they manufacture brackets and walkways. Well, before ending, the final remark is we need to improve collection of end-of-life fishing gears across Norwegian coast. Why do we have so much leakage across Norwegian coast? Is if you see the map of Norway, Norway has around 4,400, more than 4,500 ports, registered, non-registered, just because of the bird claw geography that Norway has. There are so many ports, and if you look at Denmark or, for example, Scotland has 36 ports, or Denmark has 18 registered ports, and then managing those many ports is much easier than managing the number that I'm presenting over here. So in European Union, it is mandatory to have a port reception facility at each and every port in the European and EEA states. The port reception facility is nothing but a dustbin, so where fishers and everyone can dispose of their fishing gears, so that there is no leakage through land-based sources, or they are not forced to put this thing in the ocean when the worn out gears in the ocean. So in Norway, only 1/3 ports have this particular facility. Landfill tax, take back schemes, extended producer responsibility, or penalty schemes. These are some of the schemes that I have elaborated in the study, which can be used to curb this particular flows that are entering in the ocean from land-based sources, from fishing. And of course, waste reduction is effective than cleaning. You spend tons of money in taking out waste plastics from fishing sector, from the within Norway, but that all those particular efforts combiningly not even removing 1/3 of the plastic that is entering in the ocean. So we have to find out efficient reduction strategies at this stage. Fisher's knowledge is a key resource when especially when the data is not available. So you have to go back and talk to resource users to get more information about the resource uh, consumption. Effective policy instruments are required, and we must ensure sustainability while closing the loop for plastics in Norway. By that I mean we also studied how current recycling method of sending everything across the border in Norway, if you use that as a recycling solution versus you recycle everything within Norway, and if you compare that with other end of life options such as landfilling or incineration, uh, we have done that sort of comparative analysis, and that's why a sustainable solution in one region cannot be a sustainable solution in another region. So that's why I like what Julia also mentioned in her last presentation. System boundary is very important when you discuss sustainability. And while going for circular economy and recycling and all these aspects, we have to always make sure that what circular options we are or strategies we are suggesting are also sustainable and also economically feasible. Otherwise, it's just words on the paper, and that's not going to happen in the reality. So that's all from my side. Thank you.
Thank you very much, Paratosh. Very interesting presentation. I had no clue how much plastic was coming from Norway, so that's actually kind of scary. Also, even though I'm in this sector, I actually didn't know how big these nets were, so that's also impressive. Do we have any questions from the floor? I think we just have a couple of minutes for questions. Does anyone have anything for Paratosh? No, I thought maybe, oh, Julia, go ahead.
Oh, great talk, Paratosh. That was really fascinating and extremely thorough and painstaking looking work there. So something struck me when you showed the map of Norway at the end and the Gulf Stream. And I was just wondering about, thinking about the flows from Norway going to the sea and then, I don't know, the circular flow there. And so kind of when you worked out how much was going into the ocean, I mean, did you take into account movement of plastics from outside of Norway?
Yeah, that's a very good question. And the answer is no, because that's why we had to make a static MFA. So we are just looking at the snapshot of whatever happened in that 1 year. So if you lose 400 tons of plastics in the ocean, and by means of collection from the ocean, or also when volunteers collect plastics from the beaches, they are not necessarily the same plastic that is lost in the ocean. They might be lost in like 10 years ago or 15 years ago, or also as you said, it's a transboundary problem. Plastic pollution is uh, that's why we find many plastic nets that are flowing through the undercurrent ocean waves, and then they reach to Svalbard or even Canada, for example, and you can source that back to Norwegian fisheries. And in Norway, you can source back some fishing gears that are Russian made, or from Spain or some other countries. So another scheme that we have proposed over here is marking of fishing gears, which is also been widely talked about by Food and Agriculture Organization of UNFAO, so that you can at least trace back and show the polluters has to take the responsibility, and polluter pays principle can be applied. Today you cannot do that because nobody knows this net, where it's 10 years old or 15 years old or it's fresh. You never know you can't know anything. So uh, that's why we just took the snapshot. Okay, so you collect this much from the ocean. What is the weight of that? Okay, 350 tons or 50 tons, whatever it is. We have not, there is no way that you can trace back, okay, this is how much old, or is this only from Norwegian fisheries or not. So that was just whatever I presented. I openly say that this is a huge underestimate of whatever pollution that is happening in the ocean, because we do not include foreign vessels that come to Norway and fish, and Norwegian vessels that go to other waters and fish. So and also the so to say recreational fishing in Norway. Norway is a fishing nation, and recreational fishing is also a big plays a big role. And we couldn't include recreational fishers in this study because the focus was only placed on commercial fishing. So there is only so much, you know. That's the thing. It's at least a first estimate of how much plastic is entering in the ocean from fishing sector at least. So there are several policies and several associated management practices we suggested in the paper that came out 2 years ago. But then Norwegian Fishery Directorate and Norwegian Directorate of Environment are deliberating on how to use this study and the policies suggested in reality now. So hopefully things will get better.
Fantastic. Thank you.
Okay, so just being conscious of time here, I think we need to move on to our final speaker, Christina. It's my pleasure to present to you Christina. She is a circular economy advisor at TOMRA. And as I mentioned in the beginning, she, on top of her day job, she also engages in these all-female sailing trips where she actually goes and measures plastic. So Christina, the floor is yours.
Thank you so much. Thank you for having me. And I have to say, I'm really loving this program. I didn't catch the very beginning of it, but the composition of speakers and just, I love sitting in a room. I learn so much. And obviously I would love to be in a physical room with you guys, but let's hope that happens again in the future sometime. But I really loved your presentations. And it's just, for me, it really goes back to that, you know, you have a system and there's no silver bullet and everything is connected. And that's, to me, also what is so fascinating. So I'm just gonna share my screen with you guys. Wait, let's see. There we go. Now you can see it fine, I hope. Awesome.
Yes,
okay, so like Helen said, I work for TOMRA, which is, I'll get back to it a little bit, but it's a sensor technology company working with resource optimization. And I'll try to explain how we got involved in ocean plastics and how that connects to the circular economy. I mean, it's been explained already a little bit, but really studying the impacts out to sea as well in places where not many people get to go and not many people get to experience the pollution out there. And also, actually, some of the work that we did involves Jenna Janbeck and University of Georgia, really looking at the pathways, not just what happens to the plastic once it's in the ocean, but also the pathways that plastic takes. And working for TOMRA, we have a quite specific entry point to this problem. So today, more than 1 million plastic bottles are sold around the world every minute. And it's really high on the social agenda because the plastic bottle has become a symbol kind of our throwaway linear society. It's really high on the social agenda. And, you know, plastic is a wonderful material. We're good at using it, but we're not always good at designing it or managing it after end of life. So in a sense, for us working with collection technology for beverage containers, I'm sure many of you have used our machines if you live in Norway, and we are present in over 40 markets around the world as well, where that sort of on-the-go throwaway product has in many ways become a symbol for some of the challenges that we face with resource mismanagement of plastics. And for TOMRA, that journey started back in 1972. This is one of the founders, was the world's first reverse vending machine that was designed to take back milk bottles. But obviously TOMRA has grown a lot since then, and now we work across the value chain of both collection of beverage containers and plastic bottles, but also in the sorting technology side, working closely with waste management. And then how do we get from kind of that sensor technology to the ocean? Well, I'm speaking of just pastime fishing and growing up in Norway, which has the world's second longest coastline after Canada. For me, as I grew up and my granddad taught me how to fish, and my granddad taught me not to take too much, but just enough from the ocean for dinner. For a lot of people that are in this space, our relationship to the ocean has been transformed into a relationship to plastic and the plastic issue. So like Helen mentioned, I've been on a couple of all-women scientific voyages, and we've sailed with an organization called Expedition, which has been now for a few years a partner of TOMRA, working with world-leading research institutions, both University of Georgia and University of Plymouth, which might be familiar to some that do a lot of work in ocean plastic and plastic pollution. And Expedition is a series of all-women scientific voyages around the world doing research on ocean plastics and also communicating on the impact that it has on ocean health and also human health. And it's very much interdisciplinary. We're not all scientists. I'm not a scientist as such, and it's interdisciplinary to really be able to come at it from all these different angles. Like it's been said so many times already, there's no single bullet to complex issues. And sailing, I mean, this looks beautiful and lovely, but sailing out into one of the most remote places on the planet taught me a couple of tough lessons. The first one is that when we're in the Pacific Ocean, Pacific to me is, you know, Mai Tais and tropical islands, and the Pacific name, you know, it's passive, it's docile, it's known for these doldrums and quiet seas. Well, that's a lie. We sailed from Hawaii to Canada. This is about 5 a.m. in the morning. We had 40 knots of wind on the nose. The waves were up to 5 meters high. It was just a matter of holding on. And I had never sailed before I went on this trip. So very much steep learning curves, but that's how I like it. And it's beautiful as well. So this is a snapshot from a study that kind of spurred our journey. It's from University of Hawaii, where some of you may have seen this one already, where it's just basically reflecting on the gyres. So an ocean gyre is kind of these accumulation zones around in our oceans because of the tilt and rotation of the planet and currents, tides, and weather systems. You have this, for lack of a better description, massive converging systems out in our oceans. And everything that floats is ultimately going to end up there. This is a simulation of plastic leakage from land into our ocean over a 10-year period, showing where, with the models that we have available, where would it ultimately end up. One of the biggest gyre that you will see on this one, this model, is the North Pacific gyre, which you see between sort of Northern America and Asia. And it stretches from about 20 to 40 degrees north of the equator. And it's known as the biggest and most dense plastic accumulation zone on our planet. So obviously, when we went out there, thinking I knew what I knew about plastic pollution, it's hard to imagine what it would be like, but we've seen, like was mentioned, you know, we've seen thousands and not millions of pictures on the harm that ocean plastic does to our natural environment and wildlife. So it's easy to imagine, you know, we're talking about, what is it, 3 times the size of France or twice the size of Texas. It's these massive trash islands maybe that we envision. But having sailed, the route we took was from Hawaii through the Great Pacific Garbage Patch, as it's called, to Vancouver to really measure this place on our planet and what it looks like. And after having sailed for about a week and a half, not having seen a single boat, not having seen any other people than the ones that were on the boat with us, we kept seeing increasing concentrations of plastic floating by the boat. But some of us were surprised to learn that it wasn't as much a trash island that we were sailing to, but this is what it looks like. This picture is taken from the middle of the Great Pacific Garbage Patch. This picture shows millions of pieces of microplastic floating on the surface of our oceans. It's not so much a trash island, It's more a plastic soup, which obviously poses a set of challenges, both practical and economical and environmental, in terms of cleanup, and really emphasizing the need for preventative solutions. So how do we do that in science when we're out there? So we deploy, we have a wide-ranging science program that we use when we're out there. We do air samples, we do sediment samples and pathway samples, and surveys on land. And we also do samples from down in the water column. But one of the most used and common ways of assessing microplastic pollution on the surface of our ocean is this manta trawl, where it skips and floats on the surface of the ocean, and it funnels through for a small period of time every day, what we find on the surface into this net, its tail kind of, that you see on the end of it. And most days, honestly, out there, we would find up to 1,000 pieces of microplastics just from a very small intersect of the ocean surface. And as you can see, it's not just plastics. Obviously, we're catching a little bit of wildlife. Some of these blue ones you really don't want to touch because that burns. And it's also a really wide range of plastic materials, colors, shapes, sizes, everything from fragments and film to even, nurdles or pellets. So it's really getting to the source of what's ending up that far out there and what's lying at this final frontier of ocean plastic pollution. So after we have pulled the samples on board, we sift them through these sieves to look at the different sizes and types of the plastic. So we're basically sailing with a floating lab. And then this is a sample of the smallest pieces, the smallest fragments we could find. And that's me in the picture holding the vial. And it's impossible for me to see what's organic and what's plastic in this sample, which means it's impossible for wildlife to discern what's safe to eat and what isn't. And this is maybe not news to anyone who understands plastic, but it does have an impact seeing the magnitude of it out there and the abundance of the plastic, and how it's just cleanup just becomes very much a measure of damage control more than anything else. And the reason why microplastics pose such a problem as well is that there are research studies that have found that not only does plastic debris, when it's brittle and it's been broken down by wind and sun and sea and salt, not only does it release some of these chemicals back into the environment, but it also actually has this lipophilic sponge to a lot of these persistent organic pollutants that we regulate or that we've banned, but that persist. So it attracts a lot of chemicals that we can find out in the environment as well, which makes it tricky, obviously, when you have chemicals that bioaccumulate through the food chain. This is from the Ocean Cleanup in a study they did, where, it's maybe a common misconception that, we don't eat the stomach of the fish or the animal. So the plastic as such doesn't travel up the food chain. But these bioaccumulating chemicals definitely do. And there have been some studies, not conclusive, but pointing to the fact that these chemicals also have a higher impact on women because they're stored in fat and they impact female fertility. So it has really wide-reaching consequences for all of us because we're all connected to the ocean. Some of the samples that we took from the trawl and from below the ocean surface, trying to sort it on board a moving lab and a boat that really just like rocks back and forth. I don't know how many of you have been on a sailboat, but it's anything but stable. So it's very interesting to do research in those environments. But one of the really fun things that we got to do is we used an FTRI machine on board, which is the Fourier transform infrared spectroscopy, where we look at the mass of the different fragments to try to identify against the database what kind of polymer is it. And you can see this is just a snapshot of what that analysis told us, where we look at, what size is it? What does it look like? And then finding what is the best hit, because once it's that small, it's quite degraded, but we can match it with some certainty to what kind of polymer was it originally. And then finding, that around 80% of the samples are HDPE, that is again an instrument for policy change on land. So we found a lot of the focus of the research was on microplastics, because that's often, a result of larger pieces, but we did find some larger pieces as well. This is, speaking of ghost nets, you see the little orb on this one. We attached a NASA GPS tracker from University of Hawaii to one of the ghost nets that we sailed past. This is a different boat picking it up after having drifted around the Pacific Ocean for about a year, trying to understand the pattern of where it travels. And this net weighed about 4 tons when they took it on board. So they're definitely bigger pieces as well, although we know that, most of the ocean plastic waste comes from land, but a significant portion also comes from sea. And after having been at the Great Pacific Garbage Patch, switched it up a little bit and went to the smallest ocean plastic accumulation zone, which is the South Pacific Gyre. This picture is actually, I was on an expedition when COVID broke out, which was an interesting experience. So this is taken in March in the South Pacific from Cairns, which is one of the Pitcairn Islands. This is an uninhabited atoll. There are no people that live here, but plenty of seabirds. And this is a bit of this picture isn't very clear, but if we zoom in a little bit, you can see some colors on the beach that maybe don't belong there. And these are buoys and fish gears that have washed up on the beach. Some of them are even caught in the trees, which is like, this is so far from people and so far from land that this is ultimately the final frontier of ocean plastic pollution. And this is not only detrimental to our environment, but is a real financial loss as well. Because if you look at reuse of valuable materials, you have paper and steel recycling and recovery, which is sort of well-established loops around the world, and the aftermarket is quite well-established and mature as well. For some reason, plastic packaging, not so much. We estimate that even though more than 70% of plastic packaging material is completely lost with incineration or just in landfill or emitted to nature. If you look at around 14% collected for recycling, actually only 2% of it is circular, like a bottle to a bottle. But looking at the 14% that we recycle today, our estimates show that the value proposition is conservatively $50 to $80 billion a year. If we expand and include more than just plastic packaging, we're talking $170 billion a year. So there's a real economic loss to this as well. And as an example, one of the things that really we work with in TOMRA is a deposit return scheme, which is such a proven success where you add a value to something, you add 20 cents to a bottle, that incentivizes take back, that incentivizes the shift in behavior, and also builds that aftermarket and closed loop on land. You're looking at countries that don't have deposit schemes as an example for plastics. You can get recovery and recycling or recovery rates around 40%. Adding a suitable value to the material, which then plays into the extended producer responsibility schemes, you can reach the high 90s of recovery. And then that is, even in Norway, the scheme coordinator in Norway, I don't know if you've noticed, for those of you who are in Norway, but the plastic bottle can only be of a certain color. The label needs to be of a certain material. The glue, the adhesive needs to be of a certain type, and the cork needs to be of a certain material, because that is one way to design for recyclability and that closed loop. And this graph is a little bit complicated, so I won't spend too much time on it, but I'll draw your attention to the very far right side where there's a real business case for plastic. What this shows is if you don't put a sorting machine in front of a waste management plant, you can get maybe 200 euros per ton of mixed plastics, just different types, different colors in one material stream. But the more you sort it and the more you qualify the different volumes of types of plastic, you can have a 7-fold value increase on the aftermarket of different types of material. Because it's just, if you're a recycler, you want to know supply and you want to know quality. And then to sort of wrap up, when I was in the South Pacific, I got to visit this magical place, this tiny little speck of land, 5 hours by flight from Chile. This is Easter Island, or Rapa Nui, as it's called by the people who live there. Spectacular place. If you ever get the chance to go, I highly recommend it. It's such a testament to just human resilience. And a lot of the myths that we think about Easter Island aren't actually true. So it's worth going there. But this is a sacred site. These are ancestors that are, they're mystical to us because they were built and erected so long ago that it's hard for us to fathom what they actually signify. But we know that they're symbols of ancestors, and this is a religious site to the people of Rapa Nui even today. And why I'm passionate about recycling, though, and land-based solutions is because directly behind on the beach, we did just like a 5-minute cleanup. And finding this, this isn't an original picture either. We often see littered beaches, but for me, it's important that we have good systems close to the source, because this ultimately shifts, this plastic didn't come from Easter Island. It's so small and it's been out to sea for so long, but it shifts the burden of cleanup and the burden of waste management to vulnerable geographies that frustratingly are so well known in history for thriving on small geographical spaces because they live so in tune with nature. So that's one of the major challenges where you really get that socioeconomic axis playing into plastic pollution. And closing remarks, just want to say that, I've been to a place that's so far from land that if anything happened, we would be stuck out there on our own. There's no helicopter or anything that could reach us. It's the most remote place on the planet. And we saw washing baskets and toilet seats and takeaway menus float by the boat. There's no such thing as a way. Everything that we use on land, everything that we throw away that we don't look at anymore, it has to go somewhere. So it's, taking care of our oceans is very much a job that starts on land. Thank you for your attention.
Thank you so much, Christina. That was absolutely fascinating. Horrible. Also very depressing.
I know, I'm sorry.
No, but it's good that you're out there looking and trying to figure out solutions and making sure that all of us are aware of our actions. But yeah, that was actually one of the questions that I was thinking for Paratosh, like, what is the fate of all of this plastic? And that's exactly what you showed. So yeah, thanks for that. Do we have any questions from the audience to Christina about her work, either at TOMRA, doing circular economy, looking for solutions there, or for example, her work out at Ocean? Does anyone have anything?
Other than how can I join the sailing trip? That looks fun.
It is so much fun.
And depressing at the same time, I'm sure.
It is, but it kind of it just stokes a fire, right? Because we're out there, and then it's just like, if we're not doing something about it, if we're not going to be role models, how can we expect anyone else to be it? Because we've been out there and seen what, there's an estimate that maybe there's been 100 expeditions ever to the Great Pacific Garbage Patch. So then it's like, what do we do with that witness statement? So it's very much, you can just ask anyone who knows me, and I've just been beating people over the head with this for the past 3 years. But you should check out, obviously all travel and sailing is paused now, but you should check out X Expedition, because it's sailing with all women as well is well worth it.
I guess I have a more general question about raising awareness to plastic pollution and so on. So there's some evidence that suggests that negative messages have, I don't know, less of an impact just because people, I don't know, feel frustrated. Maybe the problem, the issue is too big. What can I do about it? If it's the size of Texas, right? Like, okay, so I won't use the straw. Biggie, no big deal. So I guess I'm really curious to hear your thoughts about institutional change versus the call to individuals to drive change. And I guess more specifically, do you think that that is a fair call in a way? Because ultimately there are some, so I teach my students about this and they say, oh, you could choose what you buy. I'm like, well, no, I can't really choose whether I want to buy pasta, a specific pasta. If it comes in a plastic bag, I buy it in a plastic bag. I can't choose the specific pasta to come in, I don't know, whatever, right? And so I'm just curious. It's a very complex issue. Just curious what you think about institutional responsibility versus individual and the type of message, positive versus negative, I guess.
And I think that's one thing that a lot of people in the space come back to is that particular question and that conundrum. And also just for me as well, that's one of the topics that often come up. And for me personally, I'm just sick and tired of people pointing fingers and being like, oh, it's the beverage industry. Oh, it's the plastic recyclers. Oh, it's the consumer. Oh, it's the government. If everyone's just pointing fingers and no one's changing anything, then we're not going to get anywhere. And it's clear that, you know, for plastic recyclers to want to buy recycled content and recycled material, you need an aftermarket for it. And whether it's a fair price or sort of a social premium on those products, those are all important drivers that work together. And after the national sword in China as well, you know, waste management was just, waste management has never been that busy in Europe since then, because like, oh, we have to fix our own backyards. What do we do now? So there is sort of a lot of drive and momentum there, but it needs to happen across the spectrum. And I mean, a lot of what I say is quite doom and gloom, but I try to sort of end on sometimes uplifting notes at least, because we have to work from optimism and hope. Otherwise, we're just going to give up. You know, we can't be cynical about it in that way. But what is interesting, and I don't know if you've seen Seaspiracy as well. I know some of the people that were featured in that documentary, and I won't talk too much about it because it's other people have done that. But you know, coming at saying that, oh, you don't, if you don't use that plastic straw, that's worthless. Yes and no. Because that behavioral change, which is what I showed with the deposit on bottles as well as an example, you're shifting behavior. And if we're aware, we know that the minute you go from something single use to reuse, it is once you've taken that step, we have a momentum to spur further behavioral change. So just coming from a place of educated hope, I think, and being real with the facts, because we suffered real heartbreak when we were out there, because it is devastating seeing wildlife and seabirds in this mess. But then it's, you know, anyone can, pardon my French, bitch about it, but what are you going to do? What are the solutions?
So I'm really curious if you have, so like if you have any materials like academic research that shows, let's say, you know, I would say the how do you call it? The rollout impact or the spillover effect of not going to reuse, because, you know, in life cycle assessment, I have a paper that quantifies how many times you need to use the single-use bottle for it to be better than the fountain, right? So we know in our nitty-gritty environmental accounting that, well, if you kind of lose the reusable bottle after 50 times, which I totally do, then maybe that's not so good for climate, right? So it's a really complex issue, right? What are we optimizing for, climate or plastic pollution? Or so if you have anything on the spillover effects that are not asking people, but like experimental evidence, I would love that. And I have folks at the government that were asking me if there's any research about that. And I would love to send it over, because I haven't found any good ones like
Yeah,
that.
no, I don't know if we have studies as such, but we have published a white paper on sort of good system design for take back and reuse, and how that really changes behavior in how people see something as waste and then they see it as something of value, and that transition and how that can happen over just a couple of years' time. So maybe that's a starting point. Maybe that's interesting. But we know that, you know, in Australia and New South Wales, when they implemented their deposit return scheme there, which has been a huge success, it wasn't because they were like, oh, plastic, but it was because no, real estate prices are dropping and our rivers are being polluted because litter is an issue. So it's like there we include even milk cartons in the system that we take back, where we normally just take back bottles, because the political ambition was litter reduction. But then you have systems that can really tackle that. And, you know, people tried to give back their flip-flops and whatnot. So it's very much sort of an educational exercise as well. But it's interesting that whatever the agenda from politicians and regulators, if they want to get at single use, they often implement that kind of system to begin with. And then they really expand on it in terms of purchasing power in local governments and stuff like that.
Paritosh, I see you have your hand up. I would like to give you the floor.
Yeah.
You're muted. Okay, there you go.
Yeah, sorry. So yeah, thank you, Christine, for a very nice presentation and very to the point. And I kind of envy you that I cannot join this all female expedition group, but anyway, I'll try another ways. But yeah, I mean, just to continue on Tamar's question, it was a very important question, and Christine's answer was almost to the point. And I just wanted to add something in that both we need to have like users perspective as well as institutional perspective, but more than that, it's the responsibility of we as a science practitioners to show the evidence that can enable informed decision making or informed policy making around this, be it a complex problem which is which fish feed you would go for, or which fish feed is sustainable, as Alan and Julia was talking about in their presentation, or similarly with the plastic. Many people come up with many industries are blooming in European region or almost everywhere else in the world when this Chinese ban on plastic happened in 2016, and also circular economy at the same time started blooming in this region. So what they do is they market their product as, oh, this is recycled from some plastics from fishing or plastics from some bottle or something like that, and okay, this is a new shoes that we created out of plastic fishing gears, and then if you buy this pair of shoes, if you have to pay 30 pounds or $30 extra, and then you are actually a ocean savior in that sense. So that is the marketing gimmick. Basically, if you see the whole, if you dissect the shoes and then you see that, okay, it's using hardly 3 grams of waste recycled fishing gears, and in Norway itself we have 300 to 400 tons which is available for recycling, or 4,000 tons which is available for recycling. How many pair of shoes that you need to make in order to take care of those many, like at least one country equivalent of waste fishing gears from plastics from waste fishing gears? It's enormous number. Like you will fill the entire lake by shoes that you are making out of this. So, and are you taking responsibility of that particular shoes after it reaches the end of life? Are you having some system like Tomra has for putting your recycled bottle, or are you just selling me like recycled some shoes or some bracelets that I don't need, or some goggles or some garments that I don't really need? You're just selling me like overpriced. It's kind of a greenwashing, and that's what I meant to say, that it is easier for consumer to fall prey to these greenwashing methods and spend little extra bucks and try to get that false contentment that, okay, we are saving ocean, or we are saving whatever your topics that are close to your heart says, but you are not really a part of solution over there. You are actually creating more problems, and that is how we as a scientist, I would say, need to be more responsible and show how circular economic solutions or institutional solutions or strategies are also sustainable, and they are not creating more dangers than averting the same. So that is also equally important.
Yeah, I totally agree. And it's a complicated space because you've raised some very important points. I don't fully agree that all of it is greenwashing though, but for the parlay shoes, it's like, it's a one-stop because you can't really recycle that shoe after. So you've done something good, but then that has to be incinerated. But it does help that social premium, that sort of social value of, I'm doing something good in the world. That does drive the aftermarket, so that is important. But it needs to be scalable, and we just, we need to move from that sexy social value to design and waste management a lot further up the value chain. But yeah, it's fun discussing.
Yeah, so I just wanted to cut off here because I think we're out of time, and I know we all need to move on to the next meeting and everything else. So, and I want to quickly, before everyone disappears, I want to just mention that what's next for the ISIE. It's very important that I announce that we have now opened up the Perpetual online conference to be organized by our members. So we've been so far organizing all of the sessions from each of the board members, and I am the last and final one. And now we're opening up to the rest of our members to organize sessions if they have interesting topics that they would like to organize around. We have the next session, the May session, already organized. So we don't have a date set yet, but we know that it's going to be a joint input-output and socioeconomic metabolism session. Tomer will be part of this, but we also have Dominic Wiedmer that will also be co-chairing the session. So if you are interested, please contact us. We will soon have a more professional system on our website with an abstract submission page, but this is currently under construction. But I also wanted to, before everyone disappears, thank the speakers so much for coming. We really appreciate you taking the time to do this. They were all fascinating talks. I think everyone brought in new perspectives, and I personally learned a lot. So I just really want to thank you for taking the time out of everyone's really busy days to do this. That's all from my side. I unfortunately have to run to the next meeting. But
Thank you, everyone. It was a pleasure.
Yes, thank you so much. Stay tuned for the next ISIE SEM professional conference session.
Thanks so much.
Have a good day, everyone.
Bye.
Good day. Bye-bye.
Bye.